And I would say engineering is full of mechanisms that required huge leaps of imagination and innovation. And when I look at biology, I see the same. It's full of irreducibly complex mechanisms that required great creativity, not some evolutionary process.
ID, The Future, a podcast about evolution and intelligent design.
Is life the result of purposeful design or unintended evolutionary accidents? It's an ongoing debate that's about to be impacted by new scientific evidence that suggests living things are full of optimal engineering. Welcome to ID the Future. I'm your host, Andrew McDiarmid. Today, I continue my conversation with award-winning British engineer and designer Stuart Burgess about his new book, Ultimate Engineering, which is chock full of compelling examples of advanced structures and systems in the human body and other vertebrates that go far beyond what humans have produced and point to intelligent design, not the cobbled-together results of a blind, purposeless process. Now, in case you don't know him, Dr. Burgess is Professor of Engineering Design at the University of Bristol. He has published over 200 scientific publications on the science of design in engineering and biology. In the last 3 Olympics, he was the lead transmission designer for the British Olympic cycling team, helping them on each occasion to be ranked in first place for track cycling. For the last 2 decades, his gearboxes have been used successfully on all the large Earth observation satellites of the European Space Agency. He has received many national and international awards for design, including from the Minister of State for Trade and Industry in the UK. In 2019, he was given the Top Mechanical Engineer Award in the UK out of 120,000 professional mechanical engineers. And he's been an invited speaker in over 30 countries. Welcome back to ID the Future, Stuart.
Yeah, it's good to be with you.
Well, in part 1, we discussed what you do for a living and your motivation for writing this book. We also dove into some examples of optimal engineering in human joints, the mouth and throat, the design of the eye, the biomechanics of the ear, and more. Today, we're going to look at some of the work you've done in spacecraft and rocket design and how that compares to the level of design sophistication that we're seeing in biological systems. And we'll also continue to unpack how you respond to claims of bad design. And I hope it's becoming obvious that who better than a mechanical engineer, someone who is trained and intimately acquainted with the planning and building of functional and beautiful systems and objects, who better to answer the claims of shoddy design that come from certain proponents of Darwinian evolution? All right, let's jump right back into it. Now, Stuart, you've won several national awards for spacecraft and rocket design for the European Space Agency. What were these prizes for?
Well, 2 prizes were for a new type of gearbox, which you've been mentioning, that I invented for deploying solar panels on large Earth observation satellites for ESA. This gearbox is a type of worm gearbox, except it's a very special worm gearbox because it can transform into a rack and pinion and also a screw nut mechanism, all in one mechanism, extremely difficult to design and invent. So it's really a multifunctioning mechanism. Just a couple of points I would make about this invention. It could never, ever have been the result of an evolutionary process. It is so different to anything that's come before. It was a huge leap of imagination, really difficult. And I would say engineering is full of mechanisms that required huge leaps of imagination and innovation. And when I look at biology, I see the same. It's full of irreducibly complex mechanisms that required great creativity, not some evolutionary process. Another thing I would mention about my gearbox is that it's actually simple compared to the human wrist or the human knee joints. They are multifunctioning in a much more elegant way than my gearbox. I've also won a prize for a damping mechanism for spacecraft, which I designed at Cambridge University, and that helps deployment.
Well, how does the level of design sophistication in spacecraft technology compare, and I know you're alluding to this already, but perhaps you could add to it, How does that technology compare to what we're seeing in biological systems?
Yeah, I think this is an important question. Spacecraft technology is at the forefront of human technology, yet it is actually so simple compared to biology.
Mm.
For example, a large spacecraft might contain 100,000 components. In contrast, biological system like a human being contains trillions of cells, each of which contains many complex machines that themselves contain many parts. And the integration in biology is far higher than the integration in a spacecraft. So I have found it very humbling to study biology. I've worked on some famous projects like the Hubble Space Telescope, the European Skylark rocket, the European Envisat satellite, and I've worked with some of the best designers in the world. But when I look at the design in the human being, it's very humbling. It's just on a completely different level. And that is why so many academics are seeing there is this overwhelming evidence for intelligent design.
Hmm. Well, and here's another example. How does the wiring system of a large spacecraft compare to the nervous system in the human body?
Yeah, this is something which is of interest to me because when I've designed deployment systems for the European Space Agency, as part of that project, I've actually designed the wiring system from the solar array back to the spacecraft. Now, some of these solar arrays are the size of a badminton court with 400 wires coming down to the spacecraft. So we're talking about doing 3 miles of wiring, and I've had to do that wiring. The human body contains around 60,000 miles of nerve pathways. And as I was saying before, it's really quite humbling. I'm thinking I struggled to design 3 miles of wiring, but that's just nothing compared to the human body. And what's interesting is when I look at the details of the wiring in the human body, I can really appreciate the level of detail and design. Just to give you one example, in the human skull, there are 21 prominent holes. There's a hole for the jugular veins, a hole for the optic nerves, a hole for the spinal cord. And when I was designing my wiring system for European spacecraft, I would have to put holes through beams and structures. In fact, I wasn't very popular with the structural engineers because I would put a hole just where they didn't want it. But the point is, I had to very carefully collaborate with the team, and we had to plan our holes right from the beginning of the project. It could not be designed chaotically in an evolutionary manner. Everything had to be planned right from the beginning. When you have nerve pathways or wiring, it is the most integrated part of a whole system, and it has to be planned right from the beginning. And when you look at a biological system like the human body, far more complex than a spacecraft, that has to be planned right from the start.
Yeah. Well, some people argue that the laryngeal nerve is a bad design because it appears to make a strange detour towards the heart instead of going direct from the brain to the larynx. How do you answer that in the book?
Yeah, people like Jerry Coyne has said this is supposedly nature's worst design, the laryngeal nerve. Nathan Lentz, Richard Dawkins have said the similar thing. The first thing I would say is if you have studied wiring systems, if you've studied the nervous system of the human body, you would be so humbled. You would be very hesitant to pick a criticism of this incredible system. And yet, Richard Dawkins and Jerry Coyne, they've got the nerve to criticize this system. They don't come up with a better design. They don't explain what is the problem with this detour. There's no known problem with the detour. They just think it looks wrong. Now, I have done wiring myself, as I explained. I've taught students how to do wiring. One of the things I would say to Jerry Coyne and Richard Dawkins is if you understand wiring systems, you will understand that loops are very common. If you look inside of a car or a building, you will often see loops in the wiring. One of the reasons is that it helps assembly. If you're assembling wires, it's easy for the wires to get too tight. So you put loops in to make assembly easier. I have put loops into spacecraft wires, I think, for the same reason we see a loop in the laryngeal nerve. I've put loops in there for assembly reasons. I think that's true for the laryngeal nerve because when a baby's growing in the womb, different parts of the baby grow at different rates. And therefore, you need some slack in the nerves to accommodate that different growth rate. Another reason I had loops in my spacecraft wires was so that some wires could piggyback on other wires. I had to do a detour to pick up other wires. And you see this with the laryngeal nerve because it also contains the nerve to the trachea. And so it had to do that detour in order to pick up that smaller nerve that didn't want to go on its own or couldn't go on its own. And there's even the purpose of redundancy. Because of the detour, you have a laryngeal nerve. One comes from the top, the superior nerve, and one comes from the bottom. And because of that, you have redundancy. There have been cases where a soldier has been shot in the throat and they've only lost one of the laryngeal nerves and they can still speak because the other one is still functioning, maybe not speak so well, but really speak well enough. So there are reasons if you look into this, and I explain this in my book.
Again, it comes back to having the right training, right, to answer the questions that come up as you study biological systems. Well, your book has an interesting section on the homology of the vertebrate limb pattern. This is an icon of evolution. It's claimed to be one of the strongest evidences for evolution, but you show that it actually points to intelligent design. Can you explain that?
Yes. I mean, the background to this is that Charles Darwin noticed that the limb layout of many creatures was very similar with the shoulder, elbow, wrist. For example, for humans, whales, whale flippers, bird wings, frogs, they had this very similar pattern. Now, Darwin argued that this was a key evidence for evolution, but a lot of people don't realize there was a big assumption that he was making. He was assuming that the layout was not universally optimal. If the layout was universally optimal for all creatures, then it would be explained by design, not necessarily by evolution. In particular, Darwin argued that the whale flipper was a bad design. So he said, why would a whale need an elbow, a wrist, and fingers? Surely that's a bad design. So that's the big assumption that he made. For the last 30 years, I've been studying the limbs of animals and humans, and I've come to see that the limb design is universally optimal for all creatures, even the whale flipper, i.e. the whale flipper does need a wrist. It does need fingers. It needs the muscles in the fingers. And I show that the whale flipper needs fingers and muscles in order to deform the flipper of the whale and also to fine-tune stiffness. Because of the hydrodynamics of swimming, the whale does need to use its fingers to change the shape and stiffness of the flippers. It has a big effect on the hydrodynamic efficiency. Otherwise, the drag coefficient goes up and swimming is not so efficient. Of course, Charles Darwin was not an expert in hydrodynamics. He wasn't an expert in that side of engineering. He just assumed this was a bad design. But modern research is showing that this limb design is actually universally optimal. And so I wrote a paper published in the Institute of Physics, and the very title of the paper was Universal Optimal Design of the Vertebrate Limb. So even in my title, I was challenging the homology argument. And in the introduction, in the conclusion of the paper, I said, this challenges the homology argument, i.e. I'm saying this shows that it's incorrect. It's wrong because Darwin made this mistake in assuming it was not a good design for the bird and the whale. Far better explanation is intelligent design.
You might say that Darwin was being flippant about the flipper of the whale. You know, just making that knee-jerk, ignorant, and I mean that in a respectful way, assumption, as you say, about
Mm.
about the flipper without studying it and without considering the trade-offs involved in engineering such a device. And it's telling that we're still doing that, that Darwinists are still making these assumptions, not having been adequately trained in engineering principles. So
Mhm.
we invite them to get some training in that and then come back and see if they still have the same desire to challenge these designs. Well, you have a chapter in Ultimate Engineering that shows that the biodiversity of life on Earth is best explained by intelligent design. Can you explain that?
Yeah, well, basically, a good designer has a desire to explore the design space. And I can appreciate this having designed for 40 years. Um, I enjoy designing what turned out to be the fastest bike in the world. An engineer wants to know and produce the fastest design. I enjoy designing EnviSat, which was the largest Earth observation satellite ever built. So an engineer has this desire. What's the biggest? What's the fastest? The smallest? And so if an intelligent designer has gone through the Herculean task of creating an Earth for life, it would make complete sense that they would want to explore the design space. What's the highest, the fastest, the deepest? And when I look at the world around us as an expert in design, I see exactly that. The designer has explored what is the fastest, the smallest, the biggest. Just to give you a couple of examples, dinosaurs, the largest dinosaurs, are at the limit of what is physically possible. I've actually done some research at Cambridge University on the limits of size for bridges, for animals, and dinosaurs are at the limit of size. So I would say it's not just we would expect dinosaurs. I think the intelligent designer would have to design those dinosaurs because that demonstrates his desire to explore the design space. Interestingly, blue whales are at the limit of what is possible for size in a marine creature. The limit comes down to the size of a heart. When you look at dinosaur flying creatures, they were at the limit of what is possible for flight. But you see the same exploration of limits at the smallest size and the depths of the oceans and the highest flying birds and the fastest fish. And that's not a coincidence that we see these extremes of design that, by the way, you would not expect by evolution because you need extreme solutions to get those extreme designs. I think the intelligent designer has done exactly what you'd expect to explore the design space. So I have a whole chapter explaining how we have this amazing evidence, not just for ultimate design, but ultimate diversity.
Yeah, that's very compelling. Now, your book describes how you have discussed macroevolution with many biologists and engineers in academia. Are biologists confident in macroevolution? That is large-scale change, through an evolutionary um, mechanism. What do they think about intelligent design as well? I know you've alluded to this in our previous episode, but can you reiterate?
Yeah, well, over the last 30 years in academia, I've enjoyed speaking to academics in the coffee room, engineers, biologists, and I've really enjoyed talking about origins, evolution, macroevolution. And I've really been really surprised at how friendly the discussions have been, how frank people have been with me, because the media give this impression biologists are so confident in macroevolution. Obviously, microevolution is something that does happen. But when it comes to macroevolution, what I have found is that biologists are not at all confident. In fact, the prominent evolutionist Paul Davies has actually written in one of his books that many biologists will confess in private that they have doubts about abiogenesis, macroevolution, but in public, they will not express those doubts. And that is exactly what I have found. Just to give a couple of examples, I was very friendly with a senior microbiologist in my university. He's not a religious person at all. And I said, what do you think of abiogenesis? The idea life could just arise from a chemical soup. And he said, well, it's just black magic. It's complete rubbish. And I've spoken to other professors of microbiology, and they've said similar things. In fact, the more senior you go with a biologist, the more frank they will be about the lack of evidence for abiogenesis and macroevolution. I've been, really surprised with how frank they are. But they tell me they will not say this in public because it could affect their careers. And so I find this very sad. I find it really hard to have an argument with my academic colleagues. If I say to them, I'd like to argue with you for evidence for intelligent design, they will say things like, well, don't bother arguing because I'm going to agree with you. Of course, there's evidence for intelligent design. I find it really hard to get into an argument.
Now, is that because they know you come from an engineering background and you are an authority on how systems are designed? Does that play into it, do you think?
I think partly, but I think mostly it's because they do not want to get into a debate about details of evidence because they know how strong the evidence is.
Yeah, it's a losing battle in many ways. And yet there is much to lose. And as you say, that's why they're hesitant to criticize or, speak out against the Darwinian synthesis, the neo-Darwinian synthesis today. So much to lose, tenure, grant money, reputation, position, the list goes on. Well, you've been a vocal advocate of intelligent design in academia. You've been criticized by atheists, but also supported by many academic colleagues. Can you give us a few examples?
Yeah, I have a whole chapter in my book. I think it's the final chapter, giving some interesting stories of things that have happened. So, for example, there's a big humanist group in the south of England who wrote to my head of school, my boss, and said, Professor Burgess gave a lecture on intelligent design. You need to explain to him he shouldn't do that. He's wrong. And my head of school wrote back and gave an incredibly supportive letter on my behalf saying he absolutely supported me. He explained to this group that he was not a Christian himself, but he absolutely not just supported my freedom of speech, but really supported my research. And that has happened on a few occasions. People have written to my university. My university have been very supportive of me. So, I'd like to, make note of that.
Yeah.
There have been a couple of articles in the national press in the United Kingdom critical of my views about intelligent design. But following those articles, the independent national newspaper then invited me to write a whole article in support of intelligent design. So it would be wrong to say this is a one-way street. There's just criticism of intelligent design people. There are instances. And I think there's a reason for that. My experience in academia is that most academics are agnostic. It's not true to say most academics are atheists. Most academics are agnostic, but they're very quiet agnostics. There's a very vocal minority of atheists. And my experience is when I've been really badly attacked by atheists, my agnostic colleagues have come to my help and really supported me. Normally they would be very quiet, but if you really annoy them enough, then they'll come to the rescue and support me. So yeah, I think people will find my last chapter very interesting with these stories of attack and support.
And I'm so glad that you're at an institution that values your research and is willing to stick the neck out, as it were. We need to see more of that. We need to see more courage in the realm of science from researchers, but also institutions that support research and researchers. I think that's very valuable to the scientific enterprise. Now, do you think that academia then is becoming more open to intelligent design? Do you think you'll see a point where they won't be afraid to be agnostic or to go beyond that? Or is there still going to be this fear?
I think there has been some progress. There are more ID-friendly papers. I think the work the Discovery Institute have done is really fantastic, showing really high quality publications. And in recent years, I've been able to make some statements about challenging evolutionary dogma, challenging homology arguments. So I've had a platform to make statements. So there definitely is. And in private, there's definitely progress with more academics questioning evolution. But more still needs to be done. And I think, particularly in the media have not been very good at giving enough space for the viewpoint of the intelligent design community and seeing the excellent research that ID people are doing. So I think, yeah, there's more progress to be made, but there has been some progress.
Yeah, yeah. Well, you once had support from King Charles III for your support of intelligent design. Can you explain what happened in that case?
Yeah, it's a great surprise to me. But in the year 2000, I published a book on the design argument called Hallmarks of Design. And
Mm.
King Charles wrote to me and he said he'd seen the book and he really liked it. And he was going to quote from it in his Wreath lecture. This is a big lecture that takes place in the United Kingdom. And his lecture was on respect for the earth. And he wanted to encourage people to look after the environment. And he was interested in a statement from my book, which was saying modern science has made a mistake in ruling out special creation. And he was really interested in this. And so in his speech, he said, why is it that modern science has ruled out special creation? And he said he was worried about this sweeping decision because he said, well, surely this will give people less respect for the earth. And he wants people to have more respect for the environment and the earth. So he had a different motivation to me, but he could equally see this is a mistake of modern science just to rule out, without scientific justification, to rule out intelligent design.
Hmm. That's very interesting. Yeah, and then so year 2000, that was round about when the new atheists were starting to compile evidences and put out books trying to persuade us that there is no God and that evolution is the only way to understand the origin of life. So that's a pretty neat story. Have you heard from him since?
No, not since. But yeah, it was really encouraging at the time. One of my friends said it was very brave of him to do that. But then someone else said it wasn't brave because he cannot be demoted or sacked.
He's got tenure.
Yes, exactly.
Interesting. Well, speaking of royalty, you once had a brief debate with King Richard Dawkins the great defender of evolutionary theory, which played out in the letters page of UK national newspaper The Guardian. Dawkins made this admission about you, and I wanted to read this in full because it's a gem. Maybe Burgess and McIntosh, that's one of your colleagues, are right. And all the rest of us, biologists, geologists, archaeologists, historians, chemists, physicists, cosmologists, and yes, thermodynamicists and respectable theologians, the vast majority of Nobel Prize winners, fellows of the Royal Society and of the National Academies of the world, are wrong. Not just slightly wrong, but catastrophically, appallingly, devastatingly wrong. That's Richard Dawkins trying to make you look like the fool. I know he didn't mean it as a compliment. In fact, he was basically claiming it's the entire scientific establishment versus one lowly engineer. But Dawkins's haughty words there highlight my next question for you, which is this. How is it possible that your average biologist can study the human being or another living organism and think product of blind, unguided, purposeless processes when considering its origins, and then your average mechanical engineer can look at the same thing and see examples of engineering, purposeful design? In other words, what is it about the study of engineering that can unlock the right perspective of living things?
Yeah, I mean, just to make two quick comments on that quotation, two comments. One is, of course, Richard Dawkins is wrong just to assume everyone is following the evolution paradigm. In his sarcastic comment, he's claiming that everyone is on his side, but that's just really, that's not true at all. Secondly, it's important to note that evolution origin science is a historical science. It's not an observational science. When it comes to historical science, it is possible to be catastrophically wrong. That has been proven with Piltdown Man and other fossils, which have shown to be a complete mistake. So it is possible to be catastrophically wrong in historical science. But so just to answer the question, many biologists are seeing that engineering is the key to understanding biology. I've spent a couple of summers in the States working in a biology department and giving engineering basics teaching to biology undergraduates. And it's becoming more common now for biologists to see they do need to understand engineering principles. So there's a growing awareness of that, because in engineering, you see that you have a top-down approach. You have to decide what are your constraints, what are your design goals, as we discussed earlier. What are the trade-offs? You need engineering to understand the biomechanics of living systems. I've been in discussions with biologists about how the knee works, and I start to talk about an inverted 4-bar parallelogram mechanism in the knee, and they say, "I'm sorry, what are you talking about?" And I say, "Well, if you don't understand the linkage mechanism in the knee, then you just can't begin to understand how the knee works." And so to understand from a mechanical point of view or a system point of view, you simply have to understand engineering or collaborate with an engineer, understand how machines work, understand the importance of information. So there is a growing awareness of the importance of engineering. Biology used to be considered to be chemistry, but it's not biology. Chemistry, of course, is so important in biology, but biology is chemistry and engineering and information. It's not just chemical reactions. It's an organization of chemistry, and that engineering and information is really the key to understanding biology.
So is it fair to say that this is a good reason for advocacy of having engineering classes in a biology degree? How do we move forward to actually start implementing that and bringing engineering and biology together?
Yeah, I think this is really important. Of course, biology is a difficult subject with lots of information, but I think you definitely need engineering in a biology class. Engineers know that you have to study maths to understand engineering, but in the same way, you really have to have basic engineering knowledge to understand biology. Otherwise, you do not understand the mechanics of what is happening in your biological systems.
Yeah. Well, Stuart, a final question for you today. If you had to choose and share with someone who is new to ID or had their doubts, what do you think the most powerful examples of intelligent design are? I know you could just at this point give them your book, which would be great, but what would you actually say to someone who's skeptical or doubting or wants more information on intelligent design?
I would say the human brain, the human hands, and human feet. These are the three things that really set us apart from all of the animals. Unique structure, unique abilities. These things make us really highly creative, very skillful. Those things show that we are very different to the animals. And I would say it's exactly what you would expect from an intelligent designer. If you've created a universe and an earth full of life, why wouldn't you create a particular creature that could appreciate the beauty and the design of the rest of the universe? I've heard other people say one of the reasons they doubt evolution is, according to evolution, the world could be here without humans to appreciate it. And what's the whole point of the whole universe being here without mankind to appreciate that universe? So I think intelligent design really helps you to explain not just that there's a creator, but why human beings are here as well. And I also think human beings are designed to search out the answers of the universe and to seek after the creator. And I would really urge listeners to do that.
A great final point. Well, Stuart, thank you again for your time. This has been a great couple of episodes as we unpack your book. The next step, of course, is to go and get it, and I'll mention how we can do that in just a moment. But I really appreciate your time today.
Thank you. It's good to be with you.
Well, audience, you can learn more about the evidence for optimal engineering by getting your own copy of Dr. Burgess's book or buying one for that skeptical friend or family member in your life. You can order Ultimate Engineering at discovery.press. That's discovery.press. And if you haven't enjoyed the first half of this conversation, be sure to go back and listen to part 1. Well, for ID the Future, I'm Andrew McDiarmid. Thanks for joining us.
Visit us at idthefuture.com and intelligentdesign.org. This program is copyright Discovery Institute and recorded by its Center for Science and Culture.